And today and this week in general, I'm here to talk to you about how to publish your research data, FAIR principles, and how to make sure that they become available via the SIOS portal. Part of my role in UNIS now is to represent, there's quite a lot of the SIOS Data Management System Working Group, which is a collection of research institutions and data centers that contribute to SIOS. And right now I chair that group, so hopefully I should know how to do all of this. But the rest of my role is to assist you in managing your data, and I should be basically a year-round contact point for any. There's quite a lot of info. I can answer questions to provide you with assistance in many different tasks, and I'd actually expect to be contacted a little bit more often than I have been over the past year. So just remember there's quite a low threshold if you want to send me an email or we can talk about something online. Just a few things you could ask me about, for example, where do you publish your data, which data center, how to access, there's quite a lot of data sets that you're interested in, where you might want to store your data before you publish them, what data formats you could be using, how to create different data formats, including FAIR compliant files, how to write a data management plan. There's a lot of people at UNIS, well, not a lot of people, but some people were lucky enough to get RCN granted. There's quite a lot of there's a requirement now from the RCN that they should have data management plans for all the projects that they're funding. But a data management plan in brief will tell you who's responsible for the data, which data you're collecting, when you plan to publish your data and where, what formats, and over what time scale things are going to be done. There's tools to help you with this. I will not touch upon. There's quite a lot of info. I also do a bit of teaching on some courses. So if you want me to talk about any data management or FAIR data to any students, just let me know. And a variety of other things, of course, whatever you can think about. And before I jump into the rest of the presentation, I'd like to show you a page that we have recently launched on the UNIS webpage. Ingrid now is, there's quite a lot of info, not just an orphan link. I'll click this, hopefully it'll appear. So it's a step-by-step kind of guide on how to publish UNIS data. I can't find my mouse, there it is. So each of these opens up and it talks about what you can think about when it comes to publishing data, all steps in the data workflow. And if you open up one of these accordions, there's quite a lot of information in each one. This will be a living and evolving document. So if you're working through this at some point and you think, okay, this should be covered, this isn't clear, what about this? Just let me know and I will go and update this. I have admin permissions to update the whole website if I want now. So very good. And how now do I return to my presentation? One thing to the first. And of course, I'll be covering a lot of this today in this presentation, but if I could cover all of that in everything in 1 hour, that would be too good to be true, I suppose. But my full-time job now is at the Norwegian Meteorological Institute. I work in Oslo, and working here has taught me a lot about data that I'd like to share with you today. So one thing to the first paid to develop and maintain operational systems. So the data come in and are processed through automated workflows, and they go into services that are benefiting society. For example, we run the FAIR web page along with NRK. You have no idea how many people think it's funny to blame me for the weather since I've been working at Met, and everyone thinks I'm the first person to make that joke. We have I'm working in several projects with satellite data, one with the European Space Agency and one with the Norwegian Space Agency. And we work on the flow of data and try and make them easier for use to access. If you want satellite data, let me know. And we have another example from the Cryosphere project. This is what most of a lot of different sea ice projects, like the sea ice concentration maps that they provide daily, you can see here. And I don't need to tell you how important all of these services are and what the benefits of these are. So at Met, data are really the most important thing in the services that we build around them. We write papers and do conventional research too, but this is what most of our funding comes from. And being part of an environment that works like this has really made me realize how important scientific data are and can be, and has inspired me to think of what we can achieve over the next years and decades if we recalibrate how we think about data and work with them. So I'll give you a taste of some other data services that exist and how they contribute. But you can integrate more. There's a host of different integrated data products. So you can have global data sets of seawater temperature at the surface. This is the sea ice concentration products, these surface temperature anomalies. Some can be more local scale, like snow cover. This is salinity, I believe. And for most of it, you can integrate more. You can access data from any day, going back any decades in some cases. So if you want to access any data like this, you're absolutely encouraged to go and find them and use them to complement your own work. And if you need help with that, just let me know. These data are mostly derived from large products like satellite data, but you can integrate more small-scale data sets into these, like weather stations, for example. There's GBIF. This is one of the best examples of a data service where you have contributions from not just a single project or source, but from multiple different sources. What you see here is a map of all the data that have been not just observed, but recorded around the world. And one point in here is one observation, and it could be from some scientific data set, but it could also be some hobbyist with a smartphone taking a picture of it and posting the data. But the great thing about this is that the data can be aggregated together and downloaded into a single CSV file that the data user can use. So this is a great example of even how even the smallest of data sets can contribute to something much bigger if they're published in the correct way. Data, the more you... It's an exciting time for data enthusiasts like me, because this year Destination Earth was launched. This will be developed further and further, but basically the aim is to develop a highly accurate digital model of the Earth to monitor the effects of natural and human activity on our planet. So scientists will be able to use this to monitor and understand data, the more you participate. And I think the plan is to get to something like a 500 by 500 meter resolution by 2030. So this is really ambitious. And there's a whole host of 20-something services that are up and running. I'm not going to talk so much more about this today, but go and have a look. And the more data get ingested into their data lake, the collection of data, the more useful this service will become. So these services and services like these that have not been developed yet can absolutely benefit from UNIS data. Compared to these larger one-off data sets like satellite data, your data are usually much higher resolution, more accurate, and you record academic issues of interesting things. But to contribute to services like this, the way data are treated at many scientific institutions needs to change from a fragmented approach, where mostly people are interested in their own data, to a kind of unified approach where data are shared both quickly and openly. And of course, I get that there's systemic issues impeding this here. Like mostly people are credited for the papers that they publish, and so there's a kind of necessity to be a little bit selfish sometimes. But I also believe that we should be the change that we want to see. And UNIS should absolutely want to contribute to services like these and contribute their data to the benefit of understand the. And UNIS should also want to use services like these. Can we integrate some of other people's data and these services into our own research? So how can our data benefit society? How can we publish data so they contribute to services like these and services that have not yet been developed? Understand the. Yeah, well, we need to publish FAIR compliant data sets to data centers that maximize the potential of our data. So what is FAIR data? Well, unfortunately, this has become a little bit of a buzzword. And when most people say that their data are fair, they really mean that their data are findable and accessible, and they either forget about or don't understand what it means for data to be interoperable and reusable. And actually, the findability is not often as good as it could be either. Data should not be something that's available on request of a corresponding author, and it should not be something that's in your supplementary materials. Your data are useful by themselves, potentially to someone who's never read your paper, who might never read your paper and might be in a completely different field of research. So I wish to a data center that someone can search through to find data that they might not be aware of, but might be interesting to them. But there are hundreds of data centers, Luke. Which should we choose? The important thing to know is not all data centers are equal. A good data center should work a little bit like Booking.com. If you can imagine that each hotel is a bit like a data set, or perhaps each room. Not quite sure what the analogy is. But Booking.com is useful because you can look for hotels in any location in the world and when the rooms are available on any day, and by several different filter options, and you can find results that are useful to you. Now, this is only possible because each hotel has been registered with Booking.com, along with all of this metadata, and this metadata is shared and is consistent between all the different hotels. And if you're running a hotel and you registered the hotel on some website that doesn't ask for all of this metadata and that isn't searchable, it'd be more or less useful. No one would find the hotel unless they're already a bit nicer, perhaps, or by some other means. So let's have a look at some good and bad data centers. Let's start with the one that we host at the Met, which is the Arctic Data Center. Voila. So you can go here and go to find data. And you see it has some similarities between Booking.com and this. The interface could be a bit nicer perhaps, but we can search by a date or a map and by some keywords from a controlled vocabulary. And we should be able to find some data that are of interest to us. Now, if we are to go to some other data centers like Zenodo, and I'm picking on Zenodo here, but there's other data centers like this that I know a lot of people publish. If you go to the top, you're interested in, for example, seawater temperature data. The only option you have is a search bar at the top. You can filter by file type and some different subjects, but most of these are not very relevant. And the first few data sets are not necessarily particularly of interest to us either. So there's no way to filter by anywhere in a map. There's no way to filter by time or what kind of data you're looking at. And of course, this is a test that you can do yourself on any data center if you're trying to review how good a data center is. Trivago is a website that brings together different hotels from booking.com, hotels.com, etc. It tells you which one has a hotel room the cheapest. And this is only possible because all of the contributing websites have some subset of the same method. Commonly used have the dates and times and the locations for hotels. And they must also allow different portals to pull their data from their websites. And this is what data access portals try to do with data. So there's hundreds of data centers, and if you're looking for data, it's commonly used that you should have to look through all of them. So data access portals try to make this easier for you by making all data relevant to either a certain topic or perhaps a certain area of interest available in one place. And for this to be possible, all contributing data centers need to provide metadata that adheres to commonly used conventions. And a lot of data centers don't really get this. They either require very little metadata from a user, or they develop their own way of recording metadata and expect data portals to come and write custom services to pull the data from that. And that's not really practical, because as you know, there's hundreds of data centers. Every change, so we could write one-off ways of harvesting it, but then what happens if they change something? Then we need to tweak our flows, and it's impossible to maintain. The conventions are useful. So when deciding which data center to publish your data to, one thing to consider is do they contribute to these data portals? We have the SIOS portal, which I will quickly open up. It's disappearing down here. Oh, I've closed it, sorry. See that this looks very similar to the one at the Arctic Data Center, but that's no surprise because it's the same people behind this. But again, you can find data regardless of where they are published. The aim here of SIOS is to make all data relevant and be available in one place. And actually, it's a bit weird that this map is focused on the northern Norway. That's probably because these first 15 data sets or something are from this region. But at the moment, SIOS is kind of looking at most of the Arctic. But this might be refined later. We also have SION, which is looking at the whole of the Arctic, and we have Polder, which is looking at both poles, and they're both quite similar. So where should we be publishing most UNIS data? And before I go into this, I don't know that there are a few exceptions, which I won't discuss too much today, but they're in the web page, or I haven't thought of them yet. We have the Arctic Data Center that we are running. UNIS are very welcome to publish any data that kind of contributes to the vision of MET. So if it's some of the work that we're doing, it could be meteorological data, sea ice data, oceanography data, physical oceanography anyway, they can be published here. You know, the Norwegian Marine Data Centre that IMR are responsible for, and this UNIS can publish any marine data here. The Polar Data Centre, run by NP, publish any data here really. Same with NERD. NERD is not run by a specific institution, so it is completely free, for now at least. It's a project funded by the Research Council of Norway. And whilst all the rest of them are kind of free if you have a small amount of data, if you're talking about terabytes of data, only NERD is currently free. Because data storage costs quite a lot if you're looking at decades. And then this is quite specific, but we have EBAS, which is apparently not an abbreviation anymore, which is run by NILU. And if you have atmospheric composition data, this might be an interesting place to publish them. So on this UNIS how to publish data page, you'll see all of this, and there's also some tips on how to get started with publishing with them, whether it's via some user interface or an email address. You can go and find all that information in one place. So what might a good data center offer to you? Well, the minimum you should expect is that you get a DOI that's unique to your data set. Most data centers give you this now, but some don't. There's some nice to haves. So if you have parent-child relationships, maybe you want to publish 10 files altogether, and you want to have a DOI and a citation, recommended citation for each child, but you also want to have them as a collection with a parent DOI and a parent citation. This is a nice way to kind of gather things together and also kind of give some emphasis to the project on the parent page. They should make it easy to find your data. You can test yourself, but also consider data access portals. Some data centers are now offering visualization. So if you publish your data in a FAIR compliant format, maybe they can have a way of, when you go to the landing page, they actually show you a plot or map of your data. This I don't see very often, but we are starting to see metrics for how often your data has been used. This could be how many times the data has been cited. You could also perhaps get statistics on number of downloads or page visits. We're not seeing this very often, but I would really like to see this more often. And I think if there's some more pressure from a scientific community, we will get there with this. You should also curate your data through time. This is really important. If you publish your data, you should expect that someone in 10 years or 20 years should still be able to access the data. So most data centers do this by running some routine that goes through every data set and kind of touches the link and makes sure it's still working. It's difficult to know whether your data center is doing this without going through the fine print, so kind of just trust me on which data centers do this, I suppose, and if you don't want to read yourself. But Zenodo at the moment is not doing this. So if you're publishing your data with Zenodo, in 20 years, there's no guarantee that the link has not, if maybe the URL has changed, maybe the data's got corrupted, there's no guarantee that someone's going to be able to access them in the future. Okay, so now we know where to publish our data. What about data formats? Firstly, what's wrong with something like this? We often see data published in some tabular format, could be CSV, could be Excel. Well, temperature of what? What are the units? What time zone are we in? Where were the data collected? Who by? All of this information could perhaps be there on some separate on the landing page of the data, but it might be that someone else has downloaded this file and sent it to you, and then you don't have access to that. So what I would say is all of this information should be available in the same, within the file, ideally. And if 3 people were working with the same type of data, and they all tried to create a CSV file like this, the chances are you would have 3 different versions of the file, and they'd all look very different. And so it makes it very difficult for someone to write a Python script or an R script or build any services to read in all 3 in exactly the same way and do something with the data. And the same is true for more technical file formats like JSON or XML. Unless you have a standardized structure and that structure is described, you run into the same problems. So what criteria should a FAIR data format have? It should have some standardized structure, so you know where the metadata will be within the file, you know where the data will be. It should include all the metadata within the file. The metadata and also the data terms should be taken from what we call controlled vocabularies. This is like a glossary of terms that are findable online. So someone can go and read a description on some web page and find exactly what is meant by each term. The file should be software independent. It's not such an issue for Excel files, which will probably be openable until the end of time. But if you have some expensive modeling software, that you shouldn't expect someone to have to pay for that or download it to have to open the data. All of these conventions and the structure of the file format should be well documented and well maintained, so that someone can go and understand that and it's not going to become unclear or outdated. And all of this together contributes to making the data machine readable. And people ask, why does it have to be machine readable? Surely human readable is good enough. Well, if we have machine readable, you can hope that the data management community will develop services that will kind of automate the processing and opening of files so that you can focus more on the research side of things. So I'll propose a few options. You have netcdf files, which are not necessarily FAIR compliant by themselves, but they are if you are making sure that they're compliant with the climate and forecast conventions, or CF. You can stick in lots of different types of data in here. Mostly they have been used for measurements of the physical environment. Could be air temperature, seawater salinity, soil moisture content, or something like this. This can be any number of dimensions. So it could be time series, vertical profiles, or maps with 2, 3, or 4 dimensions. You can also put some outputs from certain models in this. So we see a lot of climate model data in netcdf. I'm working on developing some things for point clouds. This could be DEMs, DTMs, or whatever as well. Satellite data. I've even put some flow cytometry data. There's no biologists here today, so that's probably not so interesting. I'm working on looking at sedimentary logs. Had some discussion with CF about this and whether this data can be in a CFNetCDF file. We basically just have a vertical profile of data. So at least some components of this might be able to go in here, and so on. You also have Darwin Core Archive. I'm not going to talk too much about this, but this is for biodiversity data predominantly, but it has been expanded to allow people to encode all different measurements related to those organisms as well. And this is not just biologists who should be interested in this. Some geologists or paleontologists who have fossil specimens can also use this as well. There are other formats which are FAIR compliant or more or less FAIR compliant. I'm happy to hear more about different formats that you think might be FAIR compliant. Certainly not aware of everything. We're trying to broaden our horizons at SIOS at the moment and be more open-minded to different formats, I suppose, but they have to meet certain criteria. But I want to talk a bit about why, generally speaking, it's better to have fewer data formats and fewer standards, because there's quite a lot of advantages with this. Firstly, there's less to learn. If you're going and looking at data from different disciplines and trying to pull them all together, it's easier if they're all formatted in the same file type. You don't have to learn how to pull data from different types of files. It's easier to share data between disciplines for this reason. If different disciplines are using the same kind of data types. And it makes it easier to integrate data into services and to maintain these services because, well, there's less to do. And this is why CFNet CDF are really good, because you can encode a wide range of different data within them. And this makes all of this a lot more efficient. So SIOS has some interoperability guidelines. I'm not going to open this, but this is basically a list of different, well, it includes a list of file types and some review of whether they are recommended or not. It goes well beyond the two that I've talked about today. So if you're wondering about different files, you can find this under the SIOS webpage, under data. Just let me know if you need to find it. So given that NetCDF files are so important, I should introduce you to them a little bit. There's a lot of information on the left, so I'll guide you through with some yellow. This defines the shape of the data. So this tells you that any variable below that calls these dimensions, it tells you how many points that variable will have. So then we have our variables. So we have a variable longitude, for example, that in brackets has the dimension of longitude. And that tells me straight away that this is a one-dimensional array of with 4 data points. And there's some variable attributes that describe this. So you have the units and some description. The standard name is from some controlled vocabulary. So anyone who's encoding longitude data should use this name. Sorry, and at the top also you have this sea surface skin temperature. And this is a data variable and it has in brackets 3 different dimensions. So this is then a 3-dimensional array of data. And this is actually an advantage of NetCDF over, for example, CSV or other tabular formats, in that with a table you're kind of restricted to just one dimension. Whereas if you're storing data like this, you can use them and map them straight away in the format that you want them to be. Then there's a whole long list of global attributes. Perhaps the most important is the conventions that tell you which conventions have been followed within this file, tell you and the machine. So we have the CF conventions and the attribute conventions for data discovery. And I will describe them next. How are we doing for time? Okay. So this is an incredibly long document and you don't have to read all of it, the CF conventions. But the idea is that if you're creating a NetCDF file, you can come here and look through the contents and skip through to any part that is relevant to you. So for example, if you are encoding some data with a longitude coordinate, it tells you which coordinates, which variable attributes you should be using and the units that you should be using. There's some examples of how certain types of data should be encoded. This is why this document is getting so long, because there's quite a lot of examples within this. We have the CF standard name table. So this is a controlled vocabulary of data terms. It's not a. You can go and search for this, and you can read underneath the description and some canonical units. You'll see just over here. You don't have to use these canonical units, but you have to use something physically equivalent. So if it was temperature, you could use degrees C instead of Kelvin, but you couldn't use meters, for example. And then there's a section which tells you about which attributes. So you have variable attributes that describe the data variables, and you have global attributes that describe the data set as a whole. So you can read this and see which attributes you could include. But actually, the CF is a little bit light on discovery metadata. So this is metadata that helps someone find a file. Things like the keywords, who created the file, where the data were collected, and stuff like this. So that's why usually we also try to comply with the attribute conventions for data discovery. And this page is just a list of recommended global attributes, more or less. But since recommendations are not a good way of enforcing consistency between data sets at the Arctic Data Center and SIOS, we try and encourage people to follow certain requirements instead, so they can see which attributes are really necessary and which ones are just optional. And you can of course go and find those, and this is kind of all covered in this web page, which you'll be able to look back to later, so don't worry too much about notes. Once you've finished your file, you want to also make sure that it is actually compliant with the conventions that you've said it's compliant with. So there's different compliance checkers. SIOS hosts one. You do need to have a SIOS account to use this, but there are different compliance checkers which you don't need accounts for. And basically, you can run this, upload your file and validate it, and it will spit out some error messages and tell you what you need to fix in order to make your data compliant. You can also send the data to me if you want me to check, and I will have a look for it for you and yeah, do basically the same in a human way. This is just a demonstration of how easy it can be to use netcdf files. You don't have to be an expert with coding. If you have Python installed, this is just 4 lines of code here. All we're doing is importing the Xarray library, giving it the URL of the data. This could also be the file path to where your data are on your computer. We're loading the data in, and we're just plotting them based on the variable name. And of course, you can do similar things in R, in MATLAB, whatever. It's not just one-dimensional data. You can also do this for maps of data. This is actually a 4-dimensional data set, but I'm selecting just a single time and then plotting the them with X, Y, Z for a single time slice of data. It's not much more code for you to be able to make something that looks a lot nicer. And of course, if I can write a few lines of code to do this, then data services can also be written, because netcdf files are or should be encoded in consistent ways. Visualization services can be available, which means that you don't have to write the code yourself. So this is an example of satellite data plotted over Svalbard. It's also easy to get data out of a netcdf file and dump them to a CSV file. So this is just 5 lines of code here. And the point of showing you this is just because you're publishing data in an netcdf file, it doesn't necessarily mean that the user has to take the data, access the data in a netcdf file. There are a lot of different services through SIOS and different data centers now, where you can just click on a button and download them directly into an ASCII file or a CSV file. But this doesn't work the other way around. You can't publish data in a CSV file and expect someone to get it out in a netcdf file. So when we talk about publishing data and data formats, we should think really about the format we're choosing has been the storage format, not necessarily the format for data use. Once you have machine readability, the data use should be automated anyway, at least in the future. Open dApps, pretty cool. The GUI, the GUI looks like something from the 90s, but it's very powerful. And basically this allows you to read data and stream it over the internet. So you have this data URL, and you can copy and paste this into your script. And then you can load the data in the same way that you would load in data from some file on your computer. So this is great if you have a large file, you don't have to download it and store it yourself. Of course, you need internet access to work, but mostly these days that's not a problem. You also have different function options to filter the data. You can select these checkboxes and download just certain variables if you're not interested in all of them. You also have these little boxes below the checkboxes where you can enter which times or which latitudes you're interested in. And then you can download the data directly into an ASCII file at the top. So some text file. And you'll access only that subset of the data. But also when you make these changes to this form, the data URL will change. So you can use the GUI or change the URL and stream in just a subset of the data. So if this is really handy if you have really, really large files that take a long time to open, you can just stream in a small portion of that. And that can make things a lot more efficient, and it makes it a lot easier to build operational services on top of the data as well. So yeah, it's really useful for services, but it's also quite a nice tool if you're not familiar with netcdf files, and you can use an interface to access them instead of Python or something. There's also, I'm not going to go through this now, but there's a spreadsheet template generator that I developed, and there's a configuration for CF netcdf that will allow you to include all the metadata you need in one Excel sheet. And in another sheet, you'll have column headers that are each taken from a CF standard names, and you can come and go and check which different files you want to access. So, we acknowledge that people still want to use tools like Excel for their work. But if they're doing this, it's nice to have structured files, and then it becomes a lot easier to convert them to FAIR compliant data formats later. Should all data be FAIR compliant? This is a bit of a contentious topic. Some would say yes. I think probably most people would say no. Well, what does the UNIS data policy say? We say that all data are published in a self-describing form where possible. And where this is not possible, we should have a detailed product manual that will be linked to the data sets. So what does that look like? So why is this? Well, sometimes a suitable data format's not available. You know, not CFNet CDF files are not suitable for everything. Sometimes it's just impractical. You maybe have loads and loads of different variables, and it might not, you can kind of fit it into the file, but it's not really going to be very neat. It can also be quite time consuming. And if the data are not, if you've got like, if it's very unlikely that anyone's ever going to be interested in these data, we measure a very wide range of weird things, then perhaps it's not necessary to invest all the time in that. But if you have a really large and diverse data set, you should still think, okay, I've got these key variables, and these are going to be of interest. So in this case, we should still be trying to put these variables in FAIR compliant formats and stick the rest in a different file, perhaps. And if you're not sure whether your data should be FAIR compliant, it's always going to be kind of on a case-by-case basis. You can just contact me. So if we're not making our data FAIR compliant, what does it mean for data to be human readable? Because it's not just publishing the Excel file in the format that you've been working with it. Each of the terms could be column headers, it could be keys in a JSON file or something, should be quite descriptive. You can take still terms from controlled vocabularies where possible. Try to avoid abbreviations. And don't rely on cell formatting or something else to make your data understandable, because as soon as you open this in with any software that's not Excel, people are going to lose that formatting. You're not going to be able to see that. Ideally, strive for software-independent files. I prefer to see people publishing CSV than Excel files. There are some benefits of Excel in some cases. Templates are nice. So the advantage here is that if one person is making a template, then it makes it easier to record the data in those later, and anyone who's used that template is then familiar with those. If communities develop templates, it's then very easy to share data within that community, and people don't have to learn how the file is structured. And you should always be including and publishing a README alongside your files. So this should include descriptions for all your terms, what units you're using, maybe a paragraph or two about describing the data. Remember, people might not have read your paper. And ideally, this should be in PDF format, so no one can edit it, or not easily anyway. But it's our job as data managers to develop tools and services to make publishing and accessing data easier for you. It's also our job to teach you how to do this and use these services. And I think as a data management community, we should really be doing more than we're using, more than we currently are. And there's a learning curve with this process, of course. But I've helped a lot of people through this, and I know that once you've done it a few times, it does get easier, and a lot of people are now kind of doing it themselves and not contacting me. Maybe that's why this room is so empty. Maybe people know how to do it. So here's what I recommend, some help that we have. We have different Python and R tutorials for CFNet CDF. This is a range of different notebooks with code and explanations. I host a YouTube channel. Most of you will probably be aware of this. And a lot of videos are encoded within the tutorials and vice versa. There are tools to convert data from tabular formats like ASCII or Excel into CF EDF. This is Rosetta, so this is kind of a way of using a user interface to do the conversion for you. We've talked about the compliance checkers. And what I found to be the really nice thing that seems to work is these workshops. And this is what I'll be running over the next day and a half.